Hi, I'm pretty hopeful that you all people are doing great. And today we are going to study number systems in AS Computer Science. So let's start. Before going into the topic, let's have a quick review that from where you can get the resources and how you can actually put them in help. So let's have a look. You have this website which you can use for your resources. You can simply go to AS level and you can get all the booklets, the topical notes, past papers and marking scheme. So I will be referring those notes again and again. My regular candidates must have those booklets with them in a printed form already. Then we have our GitHub account and AS820. You can go into AS and you can tap all the programs that we will be executing and running. And you definitely have get hold on the same programs from here, which you can run for practice from your homes. Then we have this YouTube channel, which will really going to support you, like all the videos will be there in a recorded form. Then this page, we do have WhatsApp. You can just talk to me one-on-one or in the groups, but you can use this page. The reason is that because once you go into the search bar, and after going into the search bar, for example, if you search any particular topic that you are looking for right now, let's say you're looking for bubble sort, right? And you just search it in the group. What you're going to see that immediate programs, all the discussions, all the questions are which have been frequently asked by the people around the world, they're here. So you just look into it. If you just want to search some topic of AS Computer Science, instead of googling it, just come to the page and try to find it here. So you will gonna find the targeted answers according to our syllabus. So this group can bring a really good help. Okay, let's start with the topic. So let's start with the number system conversion. I have notes open in front of me. You can have the same notes in front of you while you're just taking this lecture class. The basic conversions are there in the beginning, hexadecimal, decimal and binary. All the conversions in between, which you guys are pretty good at already. So from there we'll start. 2's complement. So how does 2's complement work? There are two different methods. Both of them actually need to be done today. Let's start doing it. Alright. So okay, let's start 2's complement. 2's complement basically means that how you can represent signed number inside computer. So far, before starting the 2's complement, let's have a quick recap. For example, if you have a number like this 105, let's say, and you have to store it in an 8-bit register like this, you know that the power goes like this. Okay, so if you have a number like this here, and if you need to convert it, you can simply do it by this. Let's say you need to make it 105, 64 and 32 makes 96, 96 and 8, 104, and there you go. This is your 105. So if you have an 8-bit register, you can store your 105 like this. If you don't have any sign with the number, we call it unsigned integers, because you don't have any sign with it. So the problem is already solved, because whenever in maths and mathematics, when you do not have a sign, it means that number will be positive. So you don't have to worry about it. So if any number that is given to you and it's been told that it's an unsigned number or the sign is not given, you simply just convert it like this. Simple, just like we used to do in O levels, or if you haven't done O levels, you can watch the videos, the basic conversion. So this is how the unsigned integers are being taken care of. If they will going to mention in A levels in AS, they will going to mention that this is a 2's complement number, this is a signed integer, so then you have to take care of that thing differently if it's being mentioned. For example, if we have a 8-bit register like this, it's been given, and they have told us that it's a signed integer, it's a 2's complement integer. So the left, this is what we call as the least significant bit. Alright, this is the name of the bits when we mention that this integer, the value that we're going to store in this particular register, this register will going to hold a signed integer. So then we just start naming things like this, LSB and MSB, which is known as most significant bit, the bit which has the maximum power. Okay. So this will be the most significant bit, and this bit will be used as to represent sign. Either it's a positive or either it's a negative. Okay. So for positive sign, 0 must be there in MSB. For negative sign, 1 must be there in MSB. Okay. Now how it's being done, how it will be done. Let's say if we have a value like this, plus 97, let's say. It's a signed integer, it's a 2's complement integer, and the plus sign holds, it's a plus sign. You simply need to put what here? Okay, let's start numbering this. 1, 2, 4, 8, 16, 32, 64. Minus 128. The MSB will have the value with a negative sign. Okay, in 2's complement in signed integers. So if we need to represent plus 97, we already know that the MSB power will be 0. Okay. Now you just need to take care of this like we already used to take care of. 97. 64, 32, 96, 97. There you go. This is your plus 97. Nothing is changed. Only thing is that the reason is that because the MSB having power minus 128 has 0 beneath it, so no issues. What if we need to represent minus 97? Let's see. In 2's complement, you have a 2, 3, 4, 5, 6, 7. You have an 8-bit register. The power goes like this: 1, 2, 4, 8, 16, 32, 64 minus 128 because it's a signed integer. And we know that for a negative sign in MSB, we need to put 1 here. If we were going to put 1 here, what will happen? The number that we will going to have here is minus 128, because already above there you have noticed it that you have a number 64 adding with 32 adding with 1, 97. Now you have already switched on the negative power, minus 128. Rest of the powers are positive. What to add inside this minus 128? That it will become minus 97. So this is how you take care of these 2's complement. For example, now you have to think in a reverse order. What to add in minus 128? You can just do a little bit homework like this. 128, 97, 1, 12 out of 3, it's 3. So 31. It means you have to add 31 to make it minus 97. Good. Alright, so we need to make 31. 16, 8, 24, 28, 30, 31. And even if you just want to do a little bit homework here, minus 97. So there you go. This is your minus 97. Alright, so let's talk another way. Because this is one simpler way of doing it. What is the reason of talking about 1's and 2's complement or the 2's complement number? There is a method. So we need to convert the same number minus 97 using another method. We need to learn that method because it's part of our syllabus. And let's solve it above here. So there we go. Minus 97. The another way is you first find out the positive 97. If you're going to convert a number with a negative sign, try to first find out the positive value of it. So plus 97 is pretty easy. Using a 8-bit register. So 0 goes there. 64 and 32, 96, 0, 0, 0, 0, 97. So this is our 97, positive 97. The 1's complement means flipping all the bits. So this is the second method, the important one. Basically when it comes to computers, if you guys were going to study in engineering or in computer sciences above and you were going to study about the circuits and all that stuff, you will come to know that to represent a negative number, there is an actual circuitry. And computer represent negative numbers by adding values. There's one big fascination, just like everything goes binary ones and zeros in computers. Either due to multiplication, subtraction, division, at the very end only addition happens. Okay, so this is something deep, but right now I just want to let you know that how you are going to do that, how to represent the negative number in method number 2 is to simply take a positive number first. For example, if we have minus 97, first try to find out the positive plus 97. We have it here. Now flip every bit. For example, this is 1, it's flipped at 0. 1, 1, 1, 1, 0, 0, and 1. Every bit is flipped. After flipping the bits, what does 2's complement means? 2's complement means adding 1 at LSB. You have to add plus 1 at LSB right here. So when you add 1, it will become like this: 1, 1, 1, 1, 1, 0, 0, and 1. So this will be your answer. Now you can simply compare this answer with this one. Is it not similar? It is similar. So we have used two different methods to find out the same answer. You can use any one. Some people feel this is easy, some feel like this one is easy. It's totally up to you. Because in exam, you should know about both of the methods. I'm not going to suggest you that you just stick to one. Okay. Like we have almost done with 2's complement, but there can be one trick. The trick is the binary addition. Okay, so let me give you a little hint of binary addition. How does it work? Because surprisingly, we had 0 here at the top. What if it would be 1? 1 and 1 will become 2. We cannot write 2 here because it's a binary value. So how it will be done? Let's take an example. Let's take an example which number have a value 1 here. It's coming 1 here. Let's see. While I just let you know about the binary addition, you're going to have an idea about it. Binary addition, pretty simple. You know that 0 plus 0 becomes 0. 0, 1 become 1. Or 1, 0 become 1. 1 and 1 become 2. But 1 is the maximum number, so how are you going to represent it? The sum will be 0 and you have 1 as a carry, it should be carried forward. Or you can simply also say that because 1, 2, 4, 8, just for the reminder, in binary, how do you represent 2? 0, 0, 1, 0. Or you can simply say 1, 0. Alright? So 0 is the sum and 1 is the carry. This is the 2. So what if you come across with the like a situation in binary addition, like you have some value like this, okay, and you have to, like this, add 1. And look carefully. 1 and 1, sum will be 0, 1 will be carried. Again it's 1 and 1, sum will be 0, 1 will be carried. Again it's 1 and 1, 0, 1. 1 and 1, 0, 1, 1. So this will become like this. So this is your binary addition, which you can apply in 1s and 2s complement. Okay, now let's have a look on the past papers. So how you can take help from there. Use a similar booklet, and after the notes, go down, 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 down. Okay, there we go. And you have lots of questions relevant to conversions. Let's pick a question here. Yeah, it's page number 39. Okay, the booklet 1.1 data representation. Using 2's complement, show how the following ternary numbers should be stored in an 8-bit register. It's 2's complement. Whenever they're going to mention it, it's a 2's complement. We already know that the MSB will be the bit used to store the sign, or it has a negative value. So 1, 2, 4, 8, 16, 32, 64, minus 128. It's a positive number, so 124, 96, it will become 106, 112, 120, 124. And if minus 77, 1, 2, 4, 8, 16, 32, 64, minus 128, we know that it's a minus value, so 1 will goes there. 128, 77, 1, and it will be 5. So we need to add 51 into minus 128 to make minus 77. So 51, 32 and 16 is 48, 48 and 8 is 48, 50, 51. There you go. Minus 77. Convert these two numbers into hexadecimal. You can do that. Simply convert this and this, making pairs of 4 and 4. You know how to convert a binary value into hexadecimal pretty hopefully. Elsewise, you can go to O-levels and have a look. BCD, binary coded decimal. It's pretty simple and easy thing. There's nothing special in it. The only thing in BCD is, for example, if any value, any number is given like this one, 3, 5, 7, whatever, you just give every number 4 bits. Every number 4 bits. 3, 1, 2, 4, 8, you know that. This is your 3. 5, 1 and 1, 2, 4, 8, right? 1 and 1, 0, 0, 7, 1, 1, 1, 0. So maximum number that you can represent in BCD is 9. You cannot go above 9 because 10 cannot be represented. In binary coded decimal, the numbers are like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But you will not going to take care of it like if you're converting a decimal value into binary. This is BCD. You give every number 4 bits. So for example, write the number 359 in BCD form. 3, this is your 3. Okay. 1, 2, 4, 8. Now 5, 1, 2, 4, 8. This is your 0101. This is your 5 and 9. 1, 2, 4, 8. And this is your 9. So this will be the answer. Answer will be 001101011001. There you go. BCD. The uses of BCD used to represent your values in lifts, in petrol pumps, gas stations where you use the 7-segment displays, or when you use the LCD screens, etc. etc. So this is your past papers. So rest of the past paper questions, they're fun, and just let me know if you feel any difficulty from number system conversions. You just can comment on the videos, you can WhatsApp me, you can talk to over the Facebook group. Everything is open. Show enthusiasm. We just really wish you very best of luck for your examinations or the predicted grades. All the best. Wish you good of luck. Khuda Hafiz.